Hello and welcome everyone to the Adventures Club of Los Angeles, our Thursday night broadcast. Really appreciate you tuning in. We're going to have a fun and interesting session tonight. We've got on board one of our members, Professor Joe Valencic. He's a researcher, an inventor. He's done some kind of crazy things with technology that I think you'll appreciate. And so we've invited him here to talk about some of those. We've got a little bit of video and some show and tell. And I expect this is going to be an interesting evening. So Joe, welcome to the Adventurers Club remotely. Thanks for joining us tonight.
Thank you, Ken. It's great to be here with all the fellow adventurers.
So Joe, tell us a little bit about, you've got a big focus in technology and adapting that to research and some other kind of creative, strange things. Tell us a little bit about your history and how you got from wherever you first got an interest in these things to where you are now.
Well, I think a lot of it started after I got my degree. I decided that underwater technology was pretty much my focus. So as a professor of marine science and technology, there's two courses that I taught that were kind of interesting in our marine technology program. One of them was advanced underwater research methods, and the second one was scientific underwater photography. Of course, this goes back many, many years ago when the Nikonus camera was just introduced. And I saw the future from the Nikonus evolve into the video. And so I decided to buy one of the first video cameras that were available in the United States. I built a fiberglass housing, and I was invited down to Scripps at an AAUS meeting, American Academy of Underwater Scientists. And so I gave a presentation documenting the marine life at Catalina Island with the first underwater color video. And a hand came up in the audience, and it turned out to be Dr. Bill Hamner. And Bill was the krill expert of the world, worked with National Geographic on a couple of specials. And his question was simple. He said, this is all well and good for Catalina, but can it work in ice and freezing conditions? I thought for a minute and I said, well, Bill, we could put in some strip heaters. We could add some high power battery. I can't see any reason why it wouldn't. And so I found myself 2 weeks later on an aircraft bound for Antarctica to work with Bill Hamner, documenting the underwater life of the Antarctic. Wow. And so the first video clip I'd like to show you is to take you down and show you what that was like. So let's use the first clip then for the video Underwater Antarctica. So if you can put that on. Okay, I've done many field expeditions. Again, this is the one in Antarctic. You can see in the left-hand side, the kind of hole we had to blast to get in the water. I really believe in field technology. So to transfer the image as well as collect them. We've just entered a hole that we blasted in the ice, which is about, in this case, about 12 feet deep at Explorers Cove. The visibility that you're looking at there is 600 feet. Now we can measure that by the light in the background, which was the Willie runway for the airplanes coming in there. So we're down underneath probably about 10 to 12 feet of ice. And our job then is to look at unusual marine creatures. Now, nobody else has documented this before. Now, well, some of you may say, you know, this video is kind of fuzzy, but remember, this video is 38 years old. Now, that's a giant sponge that we saw. We age-dated the spicules. They were 500 years old. Here we have a crinoid. Many of you are familiar with this, but this is the first time I think we were able to observe it actually articulating its rays, its arms, to swim. Now, the question was, why would it do this? It's because energy is at a premium in the Antarctic. Well, the reason is to avoid predation. Another thing we didn't expect to find down there, remember we're 50 miles from the nearest open ocean, is jellyfish that have bell diameters between 2 and 3 feet and 30-foot long tentacles. Now, as we're swimming around this one, you'll notice something interesting. The top of the surface of the ice end is not white or blue, it's green. The reason is this was taken in the austral summer, which is about December. We have a lot of light, so what we're looking at is a phytoplankton bloom. So all the diatoms and microalgae underneath the ice feed these creatures. This is at the base of a glacier. So if you've ever wondered what happens when a glacier comes down into water, this is it. The animals there have moved along the bottom until they hit this 25-foot or 30-foot high wall of ice and can move no further. So they're sort of trapped there. Now the question is, why would they go down? Why would they move into the glacier? Well, again, food is at a premium down there, so they're trying to eke out what little food they have that has been pushed in by the glacier as it moves and scours the bottom. Now these are scallops, Adamasium quebeci. You can see the abundance down there. Again, some brittle stars that we have. There's not a lot of diversity down there, but the animals that have adapted survive quite well. Now we're diving underneath the ice. You can see these ice stalactites, as we call them. Of course, we're using the DUI dry suits. Now that's our hole that we get out. We have to keep track of that. We're not using lines or strobes or anything like that. We always have to keep in mind where that 3-foot entrance hole is.
You don't want to lose that.
So anyway, that will show you a little bit of the Antarctic and that scallop swimming around. Building a shell costs a lot of energy. So these shells are paper thin, allowing the scallops to move. And they move in by sucking water, almost in a reverse jet propulsion mode, and then drifting down to a different area, again, to avoid predation, which is primarily sea stars. So you can see them landing on the bottom. And of course, it's like a dance of the scallops as they head off into the darkness down there. So scouring the bottom, easy to find 10, 15, 20 scallops per square meter. Here's a fish called a histiodraca. My partner picks it up and will instantly drop it because its spine penetrated through 3 layers of his gloves and actually gave him a little shock, a little spine, much like a scorpion fish. There's no corals. This is a giant sponge that you see down there. And of course, our no decompression dives, we come up to the surface and we do something kind of interesting. We overinflate our suits, we flip upside down, and we walk underneath the ice. Now, when I show this to my students, I say, oh, isn't it interesting? Because actually down there, it looks like we're breathing helium because you look at the bubbles. Now I'm standing upside down with my camera. The diver is exiting the hole here. And believe me, it blows my students away. I have everybody's attention trying to figure out how I've done this. So we come up and we have taken you down to the Antarctic. So I think that'll do it for that clip.
So just to be clear, you were, at that point, it was 15 miles of sheet ice over the water before you get to open ocean?
50 miles of sheet ice, 50 miles. We were at McMurdo in an area called Explorers Cove. And I'd been down there three hostile seasons, actually. We set up a hut right on the, right over the ice. And we lived in the hut. There were 5 of us from Scripps. We blasted a hole, so if conditions were inclement outside, we could actually dive under the protection of this nice, warm James Way hut.
So this was not your first adventure in Antarctic diving?
Well, I actually went down there 3 times. Every time was to document the marine life. Every time the cameras got a little bit more sophisticated. But that is really the start. That's the first time that I think that a camera was certainly used in the Antarctic. The National Geographic went the year before, but they had a black and white towed camera. So when I came back with the footage, they made a laser disc and a couple of things that people don't even know about now. But it gave me kind of a neat foothold on technology. And from there, I was invited to use that technology with some smaller cameras to do a lot of work in Dubai. Dubai has a couple of very interesting projects. They built icons, not realistic structures. And so they hired me as one of the head marine consultants and for the Palm Island of the World project. So I would like to take you to Dubai and show you how we have progressed in terms of using that basic video camera I developed into a more sophisticated technology. So if you can play that.
Before we get into the video real quick, what were they asking you to do? What was the main purpose of your visit there? In
Dubai?
Yes.
Well, it wasn't a visit. I was hired to be a consultant, which lasted a couple of years. I was never full-time. I'd go over 3 or 4 weeks at a time. My main job there was, quite honest, damage control. because the idea of building massive structures in the water meant you were potentially destroying marine life. And especially the London Times had a lot of bad press on it. I mean, Dubai is going to destroy the whole environment, they destroy the whole coral reefs. So when I went down there, the first thing I did is I made an extensive amount of dives. And I mean extensive because the deepest area where this was going to go in, the Palm Islands and all, was 30 feet deep. So we had basically no decompression dives. So diving was not really a problem. Actually, if you go into the Persian Sea or the Arabian Gulf, the deepest area there is only about 100 feet. So it's a very, very shallow area. So we could dive a lot. And in doing those dives, I found out that that whole bottom structure is nothing more than, you can think of it as consolidated calcium carbonate or like concrete with about a 1 to 2 inch veneer of sand. So as the sea moves over, the sand moves back and forth and scours any life that's there. So in doing the studies, we found a number of species of polychaete worms, and that was really about it. There was no habitat down there. So the job was, when you create the Palm Islands, you're actually going to create a rocky breakwater. You're going to use all natural materials. You're not going to pour concrete. So these breakwaters actually will act as fish condominiums. So the idea is, how much can we increase the biomass, the marine life, and make this a healthy environment rather than the Sahara Desert of the underwater area. So my job was to document it and to prove that what we were doing actually not only helped the environment, bringing back marine life by about 1,000%, but also brought back fish species that they thought were extinct.
Ah, very interesting. Okay, thank you.
So this is how we did it.
Well, let's take a look at the video.
Okay, for those of you who are not familiar with Dubai, you probably know the image of the Burj Al Arab, the only 7-star hotel in the world. And this is what they were building. This is the first Palm Island at an area called Jumeirah Beach. You can see it's based like a palm tree with an outer breakwater. A series of pictures and show the construction there. So what it's built as is the world's most exclusive fish condo. And my job then was to document how this condo of natural rocks, which were quarried, helped bring back many of these species that we didn't think was actually true. Okay, so here we are doing some research. I think there's some video on this. I don't know if you can turn up the video. Oh, maybe not. Anyway, I can narrate this. This is some of the stuff that we're using to document it. So we've gone from pure video cameras into a little bit more sophisticated technology. So we're using something that Robert Wildcraft has used. These are called AGA masks, but I built cameras into them and some sensors. So what I do is I can go down there, I can have remote cameras. Now this could be either umbilical to the surface, where we have a 4-camera screen on the surface with data monitoring. So the same time we're getting the video, we're getting GPS position, we're getting oceanographic parameters like salinity, temperature, dissolved oxygen, pH. So we correlate the marine environment, the animals living there, with the video and the GPS position. So again, here's one of those 4-quadrant views where all the composites and the data go together, and it helps us really establish a very, very good baseline. Now, this is right beyond the breakwater of what we're setting up. And so, yeah, there's a few these stakes down there. Now, what we've done is to enhance the environment, we've set up some artificial reefs. And this one particular artificial reef is actually an aircraft. We've set down 4 aircrafts, and that happened to be one of them. And I'm going to go down to the chain onto the aircraft. This is one of 2, and I think they're called Starliner jets. They were sold from the US to France. France used them for a couple of years, flew them to Dubai in an air show, and then just left them there. Well, Dubai had nothing to do with them, so we decided we could clean them up and actually put them in as an artificial reef, or what they call a FAD, fish aggregating device. And they actually work very well. Water temperature down there is very, very warm. It's in the 80 degrees. But that's not the hard thing for marine life. We have a lot of sun over there, and the sun, as we know, creates a lot of evaporation. With evaporation comes higher salinity. If we dive in the Pacific Ocean, we have a salinity of about 33 or 34 parts per thousand. In Dubai, that salinity is 30% higher. It's about 44 to 45 parts per thousand, which means if you get the salt water in your eyes, it's almost like vinegar. So these animals have adapted, even the corals, to high saline, high temperature conditions. We're underneath the landing gear, and so you can see all the fish down there. The Arabian angelfish, we bring in some spotted groupers, some garfish, a lot of fish then that are now quite happy because of the algae growth, the bryozoans, and all the food that this wreck has afforded, rather than this concrete sand environment which they previously had.
So this is a whole population that didn't exist before.
It did not exist. That's correct. So that was one of the things that was really good about actually putting these craft on. Now we also, this worked too well. We put down a 747 and we put down a Russian Airbus, which had hard landed. Okay, so we went from there, proving it, to another technology, which I'll talk about. Again, we don't have the audio on this. So you see I'm wearing a headset, but I developed a micro
one of the
miniature
fingers at
transmission
Palm
system.
into
So the antenna
the
that you
Hilton
see there
Hotel
is
where Jim Miller is recording this.
2.4 gigahertz antenna. And
Now,
I'm
in
transferring
addition,
the signal to
I
my
have
partner,
a
Jim Miller, who's
microphone
about 3 miles
that
away
is,
in the Hilton
tied back
Hotel
into Jim
in an
Miller,
air-conditioned
and on my
place,
headset,
while
I
I'm
have a
out here
tiny
in
video camera.
about
I
103
can turn this
degrees
video camera
on one
on
of the
and
fronds of
actually
the Palm
transmit
Island.
an image back
So
to
the
you.
idea is to
So let
check
me
the
give you a
link
try
on
and
this
show you what the image would
and
look like.
to
Okay, let me
actually
turn it on.
see if we
You're
can
looking directly
not only
from
make
the
the link
view
work,
from my helmet
but
cam.
actually move it
I'm
around,
pointing
do
to the
picture-in-picture,
outer
have
margin of
data
the
into it,
crescent. You can
and
see some of the
apply
very,
this
very large
technology
dredges
for
that we have
underwater use.
inside. You know,
And
point back to
that
our
was the important
microwave
thing,
grid
because
dish antenna system
now
that
I
you
can
see
take the
that,
cameras
which is
underneath
transmitting
the Palm
the
Island
signal
and with the
both
audio
audio
mask
and video
actually do some
directly to Jim
narration
Miller
to
at the
people
5th
that
floor
are
of the Hilton.
not divers, to businessmen. Okay, this is the microwave dish transferring up to Jim Miller. And of course, the project was really quite highly successful. And so we determined that the use of this is as an underwater mechanism for sending signals in the state of the health of the environment was a good thing. So we tied this into research and we tied into education, getting back to some of the schools in the Far East area.
Tied into the internet,
And I just mentioned the advantages of doing
then
this.
to transmit live audio and video might be a very, very useful
It was hot out there.
from Palm Island, both
I'll
during
bet.
construction and of
You
course
get a good tan.
even after.
I'll
You
bet.
get a good tan, yeah, that's for sure. Okay, then we got picked up by something interesting. We got picked up by the BBC. And so again, without audio, I guess I'll have to narrate this. This is a commentator from the BBC talking about some of the work that we're doing in Antarctic, using, or in Dubai on the Palm Island, using microwave technology to send back the signals. And so the images first go into the building of the palm and the fronds. You can see these things sticking out. And I'm interviewed on the boat by one of the girls from the BBC network there. We're talking about the fish and some of the work that I'm going to be doing there underwater, again with the microwave.
I think we have audio on the video.
We've spotted a
you do? Okay.
dolphin, 30 dolphin around the area. We've seen spotted stingrays, garfish, even some spotted groupers. So this indeed is a marine habitat worth looking at.
I don't know if it's coming out.
At a press
It is.
conference, live pictures
Oh, it is?
will be
Okay.
beamed back using a microwave link, including an underwater interview.
Yeah, for those of you who can't hear it, this was one of the broadcasts I did back to the Sultan and a group of very influential people. This was a control center that we had set up. And the Sultan talking about how effective this is.
With the first two stages of development costing $2 billion.
Part of the island has been designed in the shape of Arabic calligraphy. When seen from the air, it spells out an Arabic poem written by Dubai's Crown Prince Sheikh Mohammed. In keeping with Dubai's passion for racing, the translation reads, "Take wisdom from the wise, not everyone who rides is a jockey." Lisa Creffield, NBC News.
Okay, I think I will take you back to Dubai, and just to show you some of the advances in there. So we've gone from basically a camera system to now a camera system that we have tied into a mast that many divers are familiar with, the AGA mast. But what I built into it is two things. There is a small camera that fits in here, which you can take off. And then this is a television screen. So you can actually ratchet it around to see the image that you're taking, or if you're filming somebody else, you can ratchet around and they can demonstrate or do whatever they want to do in front of the camera. Now this then is set up to a microwave link to the surface and then broadcast out wherever you want to the rest of the world. I use this to do a lot of PBS television programs for kids science in Hawaii. So very useful piece of equipment that for education was good. Now, for those of you who heard the last clip on that, Linda Crawfield was saying something about a poem that the Sultan wrote about racing. And it's not just horse racing, but it's camel racing that is really pretty interesting in Dubai. And so what we're going to do now is we're going to talk a little bit about camel racing.
So this is, I have to tell you, this is the topic that when we were on our Zoom happy hour a few weeks ago, really drew my interest.
Okay, well, I'll give you sort of a background story on this too. So when I was working over in Dubai, the Sultan, who was second in charge of the country, had a number of different corporations underneath him. He had Emirates Air, he had Nihil Corporation, big financial corporation. And off to the side, there was this little thing called Special Projects with two people in it. Jim Miller, who used to be vice president at SeaWorld, and myself as Professor Joe. So we were tasked with doing maybe unusual things. So he came to me one day and he said, Professor, you have got to solve this camel problem. It's no good. And the camel problem was pretty easy because the camels have been raced in Dubai for eons. This is like their national sport. They're not bet upon like we do at one of the racetracks here, but there is individual side bets. So maybe Humvee, $500,000, etc. But those are all side bets, owner to owner. So the camel racing worked out good initially, and they brought these little boys in from the Sudan. And then the problem came in because the United Nations and the Human Resources Department said, wait a minute, are you taking advantage of these little boys? I mean, these boys are only 10, 12, 14 years old. They're tiny, 40, 50 pounds, and you're getting them to race these jockeys.
See, everything you said right there just threw off all kinds of alarms. You can see it's not sustainable.
It's not sustainable, but they went on for years. And so all of the nations over in the United Arab Emirates, Dubai, Oman, Qatar, all of them said, okay, we'll send the boys back to their home. Now, the boys went back, as you can imagine, crying because, you know, they were well-fed, they were educated and everything like that. But that's beside the point. Okay, so what I'm going to do is I'm going to take you to this interesting journey of what happened and how I involved in the project. So if we could have the next clip on camel racing in Dubai. So let's see if you can put this clip up. Okay, robotic camel jockeys. Okay. Racing camels is really the big sport down there, even more than thoroughbred. And these areas that they have are absolutely terrific. So you can see the jockeys that you have on. These are little boys weighing about 40 to 50 pounds. They come from the Sudan. And for years and years and years, until they came off, this displaced them. This is a robotic camel jockey built by the Swiss on a $100,000 grant. And they proved that they worked, and they were sold at $10,000 a piece. The camel jockeys that you see here were 40 pounds. They had the same skin coloration. They had the same sunglasses. They had the same characteristics of the boys. In other words, they were duplicating it. They even got a patent on robotic camel jockeys. And this, you see some of the early developments. This was a company in Dubai that started to make these things. They look like Buck Rogers, sold for $6,000, $7,000 a piece. You can see these huge things in there. The Afghans looked at this and says, wait, we can build a robotic camel jockey with a DeWalt drill and a garage door opener and sell it for $500 and win every race that they're in. And the reason is this unit that the Afghans built was 12 pounds versus a 40-pound robotic camel jockey costing anywhere from $5,000 to $10,000. So you can see the shops that these things are made in. And again, they have Dremel drill motors, and they have a whip, and they're controlled by a little garage door opener. And of course, the whips go down. How are they controlled? The racetrack then has two outer perimeters that the owners ride parallel with in their SUVs and Humvees. And they have garage door openers in it. So as they look at their jockey, they can engage the garage door opener. The whip can articulate, and lo and behold, theoretically, the camel is going to take off, head down the road. And here you can see the camel jockeys moving ahead, racing to that end. Again, these little things all controlled by the cars. This is broadcast on TV. You can see the TV car paralleling along. And so that was a history of the camel jockey. So you have $1 million
this is the first
camel.
operation of the
So this is one of the jockeys
Tech
that I built up first
robot.
off. So you can see I have one that's made up a lot smaller. This is only about 6 pounds.
As I energize it, I can
Now I
control
have
the speed from virtually a dead
much more
stop.
high power
And
remote
by
control on
increasing
this
it,
thing. I can
you
go
whip
forward
the
and reverse
heck out
on
of
the
this
whip.
camel.
I can do a lot of different things with this.
Now it also
I
has
also have
audio,
a
so I'll have
speaker
Jim
built
talk
into
to it.
this, so the driver can actually talk to the camel and give it ale, ale, ale. And so this then
That's a
was
6-watt amplifier
one of the
called
designs
to
that
by
I
a
came
cell
up with.
phone,
And
which could be anywhere in the world.
Afghans
End
took
of
a lot of the things that I built and the ideas and incorporated into their latest design. But anyway, this is what it looks like under the camel. You see when it's whipped, the camel actually goes crazy. Okay.
Very interesting. Seems like that outer ring with the Humvees driving around would be as exciting as the camel race.
Yeah, it's interesting. Now, that's not the real story. Now, let me tell you the real story. The real story is I was back in California in my home when I got the call about the robotic camel jockeys. And they wanted me to do something immediately to do that and bring it over to Dubai. And I said, what are the rules and regulations? There are no rules. There are no regulations. We want you to think out of the box. Get us something worthy of these camels and make sure that it's, it's incredible. So what I did is I built this thing up with brushless RC motors, but I can control the whip going forward, backward, variable speed. But I had two whips on it. I could go either side, backwards and forwards. I can control the extension of the whip and everything like that. And, that was okay. I built in a loudspeaker, and that was okay. But I wanted something unique. So I decided what I'm going to do is I'm going to nitrous the bloody camel. So how do you nitrous a camel? Easy. You get a couple of little cylinders like this. You fill one up with Epsom salts, smelling salts, and or camphor, and you fill the other one up with pure oxygen. Now you have a little electronic solenoid valve that you can control by your remote control unit. Now up in the harness, and you feed under his nostrils the little tube. So when he's coming down there, you give him a little shot then of camphor. He goes, whoa, what's happening? And then you give him a little shot of pure oxygen. You go, girl, like that. So you have nitrous to camel. So I took this system over there and I showed it to the camel jockeys. And the head of the thing came over and said, that is outlawed. You're not allowed to use it. And I said, well, there's no rules and regulations. He said, there is now.
Yes, it's definitely a game changer.
I had to rebuild the camel jockey. So I'm going to donate one to the club, and I have it here. So I have to show you. This is another version. But this is really simple. So you can make this thing really cheap. You don't need a metal stand. This is just made out of PVC pipe, but it's kind of interesting because we've got a lithium battery down in here. This is on a saddle, so it mounts right on the saddle. Here I have a speaker, the 6-watt speaker. I have an iPhone 5 here, so now I'm transmitting the video signal back in, and then the owner can talk to it through the phone into the Bluetooth. So he can control the camel, but he can also see what the camel is doing. Okay, the thing is very light. This only weighs about 3.5 pounds. And the way that it's controlled then is, if I can find it, by my opener. Oh, here it is. Okay, here's another addition I made that was illegal. What do you think it would be like to ride on a one-bladed airplane propeller? No, it whips all around. So the whip that they have actually throws the camel back and forth like this. You can see it, and he loses his stride. So what I designed is a double whip. So it has to go half the speed, half the energy, but you still hit the camel. But now you've got a nice smooth motion. Now, traditionally, this is the one that they use. So this would go on here, and this would be the whip. So instead of a little garage door opener, I used a high power one. So this will operate for maybe a half a mile or something like that. So you got the little antenna on the thing, and all you have to do is press one of the buttons. And there you have a robotic camel jockey.
That's a lot of whipping going on in a short time.
Well, I put it at high speed just to demonstrate it, but you can control the speed on that. So anyway, that was one of the far out inventions. So those of you in Dubai, go see a camel jockey.
Outstanding. Thank you.
Okay, where are we going next?
Well, I think this next topic is, I only had still photos of it that I posted on the Facebook pages and other places, but it probably got more interest than just about anything I've posted up there. And that's the great white shark. So,
Okay.
Tell us about this.
This was really an interesting project, and it goes back to the time of Jacques Cousteau, because like all of us, we always watch those programs. But the most interesting one they had, in my opinion, was years ago. Jacques Cousteau decided to do an experiment. He was down around South Africa, and he saw a lot of great white sharks hanging around the ship. So he told his men to build a great white shark, do it out of fiberglass or whatever materials that they had, and put some mechanical device in here that made it kind of move the tail a little bit and everything like that. And we'll put it on this long, heavy-duty fishing line, and we will tow it, and we'll see, what's going to happen. Are these sharks going to like it or not? So it took them a couple of weeks. They built this thing, and they towed it behind the Calypso. And sure enough, these great white sharks came up to it, and they were swimming right alongside of it. They were following this shark. And they thought, boy, this is really unusual. So this went on for about a day and a half, and Cousteau says, bring the shark in. What I want you to do is to put 30 pounds of lead to one side, and I want you in the water when it's moved to do it kind of in a jerking action like this. Okay? Now, they did that. They put the shark in the water, and after about 5 minutes, the shark leaned over to one side, and it was jerking like this. The great white sharks, instead of following them, ripped it to pieces. They just tore that thing up. So the idea behind it is, well, basically it's sick, or it's diseased or whatever, survival of the fittest, get rid of it. But the real question comes in is, why did those sharks follow in the first place? I mean, they're smarter than that. I mean, it's a fake shark, it's fiberglass. Because sharks have, one of their last senses, something called the ampules of Lorenzini, these little pressure sensitive devices in front of their snout. So they can close their eyes at the last minute and still have this last sense of these ampules of Lorenzini to come in on their prey. That sensor is highly prone to electrical impulses and electromagnetic fields in the water. So by having that motor and the electronics on board that fake fiberglass shark that Cousteau built, it was creating this electrical field. So maybe it was like a cat in heat. And the theory was they were following it because they were curious. That was it. until they found it being irregular, and then that was it. So we were approached by Discovery. Actually, a friend of mine came up with the idea of doing this thing called In the Mind of the Demon, to kind of duplicate that experiment, but build it like a shark cage and put a flex skin on it, take it to Guadalupe Island, the home of the sharks in the area, and go and swim around sharks and see what happens, and maybe even attack a shark or two. So in order to do that, we had to just sell it for Discovery. And the way that we did that is quite easy. We got Fabian Costo, which is Jacques Cousteau's grandson, to become involved in it. And with his name and a good storyline, let's show you the great white shark. So if you can put on that next series of slides. Okay, so this was it, the great white shark. This is real technology because it has a stainless steel rib cage onto it, which is nothing more than the shark cage, with flex skin. And so you can see the head on the shark and see how realistic it is. The head opens, it hinges from the bottom so a diver can get inside. Okay, this is what it looks like underwater. It's very, very realistic. Now, we took this thing in the UCLA swimming pool. We got permission to do that, and we ran all the testing there. So we got the buoyancy out of it. The tail actually moved around. So we decided what to do then is to take it into the ocean and give it some try there. You can imagine taking this thing down Pacific Coast Highway in a trailer, a 14-foot great white shark was something else. Now, my job on that was to do the TV. So I built these silicone remoras and put cameras in the inside of the remora fish and inside his eyeballs, and built a miniature television studio inside. So Fabian Costo could actually control the cameras. We used a ship called the Captain Jack, and we did all our original testing, not only off Palos Verdes, but we went over to Catalina Island. And so we were able over there to get the bugs out of it. So this will give you an idea what the shark actually looks like underwater. And again, it articulates the fin so it can actually move underwater. Now, Fabian Costo had a rebreather on. We gave him training on that. And with the working, we went down to Guadalupe Island off Mexico. So we had a aircraft that took me down there, but our boat was down there before called the Captain Jack. So if those of you who flew into Guadalupe, it was something else. So this is the Captain Jack, which was an 85-foot, it used to be an old tuna boat fish that we picked up. And we parked it in an area which was really the dining area of the great white shark. So what we did then is we set up the shark. We put Fabian Costo inside. We launched it, and we actually got an incredible amount of footage of the sharks interacting with it. Now, our job on this was also scientific. So we used this effort then to tag the sharks, put radio tags on them, and do a bunch of other stuff. So this was the crew that we had down there with Fabian off to the left. Now, I got motivated because when I came back, I lived on the lake in Lake Forest, and I decided to build myself a great white shark fin to scare the kids at Montessori School, which lived right across the lake from me. So this is a remote control great white shark fin that I built. So I would take this thing and swim this thing in front of the Montessori School. Now, if that wasn't bad enough, I built in a blood injection system in the back of this thing. So in front of the school, I would hit a button, and all of a sudden this stream of blood would come out the back of it. And these kids would go crazy. I mean, it was so disruptive. So anyway, I was far away. This was about on the other side of the lake. So they never knew that I was doing this. But anyway, I got a real kick out of this, and it's given me a lot of fun to use in different areas. I posted this on YouTube, and I got about 200 hits then on how do you build one of these things.
That's
so
great.
with that, I'm going to show you how you build one.
You should commercialize that.
Well, if anybody wants to get in the great white shark business, I'll help you. Okay, so this is the shark fin. So what we have, the fin is actually made out of styrofoam that I got from Home Depot, 2 inches of styrofoam. I kind of bonded it together. Now I drilled a hole inside to which I put a PVC pipe. So this 2-inch PVC pipe goes all the way up to the top and gives it rigidity. Now down on the bottom, what I do is I use PVC pipe. I have 2 bilge pump motors. So bilge pump starboard, bilge pump port. Now the batteries are down in here, it gives it weight. But remember, you got a lot of flotation on this thing. So I added a 5-pound or 8-pound dive weight. So it comes down, it will float right up to about here. Now, inside here, I have the batteries, but I also have a tube of red full coloring, my blood. So that goes in the tube here. And of course, when I want to, I energize the solenoid, and guess what comes out here? This nice trail of synthetic red food coloring. And so that's basically it. It's really simple to operate, and you operate it by just articulating the motors left and right, left and right. And so it swims through the water, or if you engage both motors, it'll actually swim straight ahead. So this is great white shark. Now this was a neat thing, but I decided, there's more of an application for it than just to do a great white shark. And the mechanism for building this thing it's so simple. Anybody that has an IQ higher than kelp can probably do this. And this is how you do it. These are 2 motors from bilge pumps, 12-volt motors. So you simply take off the housing. I built little domes on here. So what are these domes? It's Easter time. You get your Easter eggs, the front of the dome, plastic dome, and you fill them with foam and you glue them on there. So that makes a nice dome on here. So this is just nothing but a T-section, a 1/2-inch PVC. This is a sprinkler top, to which I have a little rod coming out, plastic rod, into a waterproof fitting. So you take this thing off, you put your battery in here, the electrolytes are in here. Lo and behold, battery gives it weight, floats in the water like this, and then you simply control it right and left going on. So you can put on anything that you want on the top. Now, I lived on a lake, and on the lake then we had a lot of Canada geese. And the Canada geese were being harassed by these 2 huge swans that we had. And the swans were killing all the babies. And so I didn't think that was pretty cool. So I decided that I'm going to import some pink flamingos and have the flamingos chase these giant swans. So I invited all these pink flamingos to come up from Venezuela. And so what I do is I put the pink flamingos right on the top here. Okay, so you can see what happens. Well, I got to move back a little bit. So as this thing's floating in the water, it's jiggling around like this, and it's going back and forth. The swans get out of there. This thing is in total control. So I've saved a lot of the baby Canadian geese just by making this little device. So use your ingenuity as to what you can come up with and put on the top of it, rather than having a pink flamingo like I did. Okay.
That's a lot of fun.
So that was a crazy thing.
So
Okay.
I have a couple questions about the great white shark.
Sure.
The second one for the Discovery Channel. Was that a towed device, or was it self-propelled, or how was that?
No, it was self-propelled. We had a system on the inside that actually articulated the fins. Remember, we set this thing up neutrally buoyant. Okay, once it's neutrally buoyant, you don't need much propulsion. So the flex fin on the back had a pivot, and so the fin would move back and forth. So it can move to some degree forward, okay?
Okay.
We weren't interested in large movements. We were just interested in movements. Now, if we wanted to move it large, which we did a couple of times, we used some weed whacker line. And we could actually tow the thing in the water, this being basically totally transparent in the water. We could actually tow it in a straight line very slowly with a little skiff. So you could do it either way.
Okay, thank you. So next thing you have to show us, I think, is critter cams.
Critter cams. Well, this started out years ago. We put cameras on a lot of different things. And, we had down in the Antarctic, Bill Hagee put them on seals and sea live, Waddell seals and everything like that. I get involved in a couple of projects with the university to put them on manta rays. And, mantas dive deep. So this is the cameras that we had for that. Of course, mantas are big. This is a steel or aluminum housing about 3/8 of an inch thick. So it's good to about 2,000 feet, glass dome on it. So this was 15 years ago, one of the smallest Sony cameras, high definition camcorders that we can get. It had magnetic triggering on the back. So they would put a device that they molded on the wings of the manta ray that had on magnesium links. So after about 2 hours, the magnesium would be eroded away by the salt water. It would float up to the surface, and it had a little strobe light. So we could wind up picking it up after that. So this expensive, it's hard, everything like that. You deal with manta rays. So I decided that I'm going to pick an animal that's a little bit easier to study, that's worthwhile. So I have a boat up in Vancouver, and I go up there quite often, and I help the Canadian government do some studies on an important resource, probably the second to salmon, and that is the Dungeness crab. So this is a legal-sized Dungeness. I'm sure all of you have had them, and you know how delicate they are. I love them too. But the crabs have an interesting feature connected with them. The end of the crabs have 2 points. Now, if we want to do a critter cam on a crab, we don't want to put on glue. We don't want to put on Velcro. We don't want to disrupt them in any way or put anything that can harm them. We only use the males, and we only use legal-sized males. So how are we going to do that? How are we going to put this thing onto them? So what I decided to do is I built a fiberglass cape to it, I call it. I put aluminum foil on here, saran wrap, little piece of fiberglass, and it actually fits like a glove on the crabs. The carapace are all the same. It's like us wearing a backpack. So how I hook them on is there are 2 rubber bands, one on this side and one on this side. So now what we do is we have a critter cam on this Dungeness crab. Now the little camera I have on here is really state of the art. This is a high definition camera. It's less than a cubic inch, and it will take HD pictures for 1.5 hours with audio. When we started out, obviously we put GoPros, but you compare a GoPro to the size of this, and then we use 3D cameras, and you again put this. So what you had is you had something that was a little bit heavy. Using these smaller cameras, what we can do is we can create a neutral buoyancy. And so the crab doesn't feel like it has anything onto it. So we catch them by trap, conventional methods. We'll put one of these little cameras on, and of course we don't want to lose them. So I use my weed whacker line, attach it on here up to the surface, 30 to 60 to 80 feet, whatever it is. And we put a little float up there. So the float, we put Larry, Jim, Harry, Ken, put their names on. And after 90 minutes, we kind of gently pull them up. Now, if they get stuck or something, all we have to do is pull it fast. And what happens, our camera will come up and the crab will go away. We try to be very slow because these crabs have produced probably a good video for us. So we're gracious hosts. So we invite them to dinner after this. So we make their night, so to speak. So that's it. This is the marvel of technology now that allows these critter cams. And these things are, they're available. I happened to pick some of these up at the CES show. This is about a year-old technology. But you can imagine a high-resolution camera that is this big, takes a micro SD drive disc into it. This thing is teeny tiny, especially when you compare this camera to, like a GoPro. I mean, it fits inside the window. It's that tiny. So it's technology like this that has really allowed us to do, some pretty interesting things. So I've got a clip of what it looks like for having a camera on a crab. This was done a couple of years ago. So you can play that clip. Okay, this is, Ken, do you have sound on this? Should have sound. Okay, look at the fish coming in there.
The Dungeness crab
There we
has
go.
a long history in the area, which was harvested by the
Yes, we have
indigenous
sound.
peoples long before the Europeans came. Its harvest is incredibly large, measuring more than about 30% of the crab catch in the Pacific Northwest. A lot of it is recreational crabbing, about 10 to 15%, the rest of it commercial. My concern is we're using this resource, we're harvesting the resource, but we know really little about its actual biology, its habitat, its food preferences. Yes, we have some ideas from logs, from records, but I like to use technology to determine what these crabs are doing. We're actually turning the crabs into the actors themselves. In other words, we're mounting cameras onto the crab, tiny cameras, high definition cameras, about the size of your thumb, and we're letting the crab let us explore not only its environment, but its food preferences and its interaction with other crabs. We're going one step further because now with technology, we can use 4K, ultra high resolution, 360-degree cameras mounted on these Dungeness crab to give us an incredible view of not only their behavior, but their activities. One of the ideas, or one of the things that we can find out with the traps is we can actually document the number of female versus males, undersized crabs, male-female ratio. And now by using the video, we can determine who is the dominant crab coming in. Does the male crab attract the females? Does the females follow the male in? Is the escape hatches on the trap significant so we can view the small crabs to ensure their survival? So all of these questions could be answered by well-documented high-resolution underwater video. And by using these cameras on trap, we get a better idea of population densities. We get an idea of movements of crabs during certain seasons, during certain periods. Having this information will greatly enhance the ability to adequately control and protect the entire population. For the past 10 years, I've used my vessel, the Pacific Odyssey, to study a wide variety of marine life, marine organisms in the Pacific Northwest. Okay, look at the fish coming in there. The Dungeness crab has a long history in the area, which was harvested by the indigenous peoples long before the Europeans came. Its harvest is incredibly large, measuring more than about 30% of the crab catch in the Pacific Northwest. A lot of it is recreational crabbing, about 10 to 15%, the rest of it commercial. My concern is we're using this resource, we're harvesting the resource, but we know really little about its actual biology, its habitat, its food preferences. Yes, we have some ideas from logs, from records, but I like to use technology.
Ken, I think this
to
is a
determine
repeat.
what these crabs are doing. We're actually turning the crabs into the
Are you
actors
playing this
themselves.
twice?
In other words, we're
Yeah, I think it
mounting
looked-
cameras
I'm
on.
summing
I
up.
think it looped, yeah, okay.
So
Well, we
pull
don't
out of
want
it.
We don't want to bore the audience here with the crabs. If I could feed them, that'd be a different story, but I can't feed them now.
So was this a one-time thing, or was this an
No, this
ongoing?
goes on and on. No, I had some special technology to actually build some sensors in to get oceanographic data. But again, with the pandemic, my boat is in Vancouver. I keep it in the water at Vancouver, and I couldn't get up there. In fact, even now, it's going to be closed at least till June, despite the fact that I've had 2 COVID shots. They still won't let Americans in there, even with 2 shots, unless you quarantine for a week in a hotel or something like that ridiculous. So hopefully I'll be able to go out this year. So we provide a lot of this stuff to the Fish and Game, California Department of Fisheries, as they're called up there, to make a prudent judgment and decisions on legal catches, traps, and everything like that.
So when COVID's over, we can get back to crab dinners, right?
Get back to, we can hire our crab models.
Very interesting. So this is an ongoing program when things get back to normal.
It's an ongoing program, and yeah, we'll apply this technology to other animals, but I can't think of another animal that is easy to catch and fun to eat.
Well, at least they have a rigid surface, so it's easier to mount things to them.
Exactly it. Yeah.
Okay. Well, last, I think we have an electric propulsion unit.
This is kind of interesting. This is my latest sort of gadget, so to speak. This is a result of self-isolation, because in February when it hit, I live by myself, and I have a pretty large house, and it's pretty well equipped in terms of producing things. So I got the idea of building some propulsion thrusters. So I saw in California that electric bikes were harder to buy than toilet paper when COVID first hit. So with all the paddle boards, all the boogie boards, all the kayaks, everything going from the shelves to people using water sports, I thought, well, maybe e-bikes means e-personal watercraft. So I decided to look into building a thruster that will go on virtually anything, any kind of craft. And so I came up with a couple of different ideas. I called it the Jet Boogie, because I work with a fellow by the name of Tom Morey, who invented the boogie board 50 years ago. Tom is a great friend of mine. He's my consultant on this. And he's going to celebrate this year the 50th anniversary of the boogie board. So I figured, Tom, wouldn't it be nice if we have an e-boogie board? Because there's going to be a big thing down at San Clemente where Tom lives and everything like that. So I said, by God, we're going to make a boogie board that's going to go like snot. And he says, I love it, you know. So we did it. So let me give you an idea what it came out as. It went through a lot of iterations, and I'll show you two of them. Let's see where I can get this. Oh, here it is. So I wanted something that could go, first off, on a paddle board, because paddle boards are probably the most used of any personal watercraft, and exercise and everything like that. But people sometimes get caught into problems. They have dogs on, they have kids on, and sometimes it's a little bit tricky getting moving around. So this is the kind of the propulsion system that I developed. This is all self-contained right now. This is the whole thing. So in here you have the batteries. And again, it's in a Pelican type case. So you simply carry the thing like this to the beach. It doesn't weigh that much. It has we'll talk about the batteries on the inside. But on the outside, then, are two thrusters. So what happens is these thrusters have special mounts on them. The thrusters come off. And the thrusters will actually mount directly on the bottom of the stand-up paddleboard, or on the keel if you have a kayak. There's a number of different ways that you can mount these things. You can keep the mounts on. So it's much like a GoPro camera. You know, everybody knows a GoPro mounts. So you can stick them on, move it off, then you can flip them back on this box, and lo and behold, you got one package that you carry around. Now, the box itself, in this case, the Pelican case, even though it's waterproof, would not be in the water. This would be on the top of the stand-up paddleboard. It would be in the canoe. It would be in the kayak. It would be on board. So the secret to success here is really coming up with the right electronics and the right batteries to make it efficient. So one of the names that I trademarked was Tesla Boogie, because I have Tesla batteries. So one of the battery arrangements that we're using are the same batteries that Tesla has in its brand new Model C. I'll give you an idea what that is. This is a standard AA cell that everybody's familiar with. This is the actual battery that Tesla fits in the Model C car, the latest Model C car. So you can see the size, larger diameter. Of course, this is a throwaway. This can be recharged 1,000 times, really has high amperage out of it. So you can run these cells, but this is not really the answer. The latest Tesla cell that's being developed right now is a supercell, which 5 times the amount of energy. So it will be something like this cell. So this will give us 5 times the amount of power. This is not done yet. I mean, they're experimenting with it, and they're building some prototype cells. LG, Panasonic, and Tesla will be producing this cell. So when it's available, we'll use this one. So we can use these, or we use another type of battery called a graphene battery. It's the latest state-of-the-art type battery. It can take a high discharge rate, extremely high energy density. And the beauty is you can buy them on Amazon. So if you want more batteries, you don't have to buy them through the vendor or anything like that. Just go on Amazon and buy as many as you want, and then you put them in the box. So the remote control that we have can be either a wireless remote control, it can be a foot switch, which is magnetic controlled. The switch is up to you. So the idea of a small thruster then, even if you had this thing on your kayak, is a long distance journey or something like that. In Vancouver, if you happen to be caught in a current or something like that, you'd simply take the box, maybe out of its hiding place or whatever, install the motors, put the box, flip the switch, and you have power against the current. So it's kind of a safety feature. But for surfboards and boogie boards, I wanted something more powerful. So I'm dealing with it. Whoops. Shut down. I'm hitting the remote control for my robotic camel jockey. There it is. Get that out of the way. So I got a much larger thruster, and I built a unit that's a little bit heavier. This is about 5 pounds. It's got the graphene batteries or the Tesla batteries, and it sort of looks like a torpedo. This thing that has a special mount, it's like industrial Velcro, and this will actually fit on the bottom of a stand-up paddleboard to the mating surface that we have that goes onto it, or a kayak or something like that, or a surfboard. This will give us probably anywhere from about 7 to maybe 10 or 11 miles an hour, depending on the batteries that you have inside. So again, it's a simple propulsion unit then, and one of the ones that we'll be using on the boogie board. So this is controlled by a little switch that I have here. So I hit the switch, it's the hand switch.
Sounds like it's got some push to it.
A tremendous amount of thrust. Again, with the batteries easy. We've done testing on the prototypes now, so now it's more thinking about getting into production one of these days. But this was a self-isolation type project.
About how much time do you get out of that?
In helping on this, let me know.
So about how much time do you get out of that, Joe? So when that's in use, given its prototype right now, but about how much time are you getting out of it? How much usage?
If you're going at high speed, you're going to probably get like 20 minutes out of it. If you go moderate speed or low speed, again, on and off like that, you'll probably get well over an hour.
Wow, that's impressive.
It was a fun project.
So I think we have some video on this one.
Oh, yes. This is the last video you're going to see. I don't think this is the one. Put on the next one.
There we go.
Okay.
Now I go back to you saying you were spending a lot of time by yourself.
Do you have the audio on this? Can they hear?
On the jet boogie. Now, to show you how it's done, we've got
There we
two
go.
cameras, one in the stern and one in the front. So let's give it a try.
So there you have it.
That's some impressive steering. Is that all thruster based?
A Cupcake is a good driver. No, that was a fixed steering, and right behind it, I put a little nozzle that kind of rotated, remote control.
Okay.
And that controlled the steering. But yeah, I tell you, talk about drawing a crowd. I think that came from Amazon for it was like $10, and I got the wig for like $7, and I went down to the thrift store, got her the outfit for $5. So Cupcake was probably the cheapest date that I've ever had.
Love it. Excellent. Well, thank you for sharing that.
You're quite welcome, Ken. My pleasure.
You have way too much fun with technology, I have to say.
Well, it's technology and adventure and research. It's all coupled into one.
Right. So I think probably time to take some questions from the audience, if you're up for that.
Absolutely.
Okay. Andy, do we have questions in the queue?
Yes, sir. Thank you so much, everyone, for tuning in. Got a good number of questions in the chat. A whole bunch just came in right now. First question from the chat from Mr. Valencic is, how do you get your inspiration?
Boy, I never really thought of that. Actually, when I'm building a project, I'll wake up early in the morning. I go to bed early and wake up early. I'll go down into my lab and I'll say, wait, I dreamt about this. This is how I can design the speed controllers. So I think when I go to sleep, I must involve these projects so much. I must be so into them where my mind is turning, and then coming back in the morning, I just put it together. But I try to do this on need too, because there was an old story about Jacques Cousteau. And Jacques Cousteau, that getting old in his age, says he's going to develop dive equipment for old people. So he developed some new kind of fins, got off the boat and tried to get in a swim, got caught into tremendous current, couldn't get back. They had to tow him back on the boat. So he was out of breath. They got him on. He said, well, I guess I had that inspiration and that one didn't work. So we go through a lot of them that don't work, but some of them work. So that's it.
For sure. Thank you so much for the answer. Next question from the chat comes from Larry Stern. Larry wants to know, do you have any patents on any of your inventions?
No, we have trademarks. Patents are extremely hard to enforce. And you might get a patent in the United States, but that isn't going to do you any good, in my opinion, because you have to go international, which becomes really expensive. So the idea is to maybe get a patent pending. And this way you'll stave people off. But, I'm just me. I'm not going up against Sony or any other company like that. So there's a couple of secrets to success, one of which is our electronic control module to develop this, for example, this jet boogie, is extremely complex. And it was developed by a friend of mine who's probably one of the best circuit board designers in the entire United States. And so this board is going to be really very difficult to copy, as well as our magnetic control switch, which is, totally waterproof. So patents, no, we can't afford them.
Good to know. Thank you so much. Next question is, how do you decide what materials to use when you construct one of your inventions?
Being a water person, and most of my inventions are in water, it generally has to be something that can be not have to be rinsed off, because a lot of this is used on my boat, which is in saltwater, and I don't have an abundance of fresh water. So my main supplier here is the plumbing department at Home Depot. Okay. That's a lot of this stuff that you see. It's PVC. It's easy to work with, easy to machine with hand tools and everything like that. I don't have a lathe. I don't have a Bridgeport mill. So most of this stuff is just done by hand. So you use a lot of epoxies, a lot of foam, and a lot of custom work. That's all there is to it. You don't need to use exotic materials for prototypes. Now, when you go into production, yeah, you can get molds and things like that made. But again, up until now, this is all small quantity stuff. If you want to build a shark fin, the materials for the shark fin in the plumbing department are going to probably cost you less than $3. couple of motors, built pump motors, maybe $15, $20 a piece. So you get some foam and you get yourself a swimming great white shark with no problem at all. Cheap remote control. So none of this is expensive, and it's all stuff that you can buy at the local hardware stores or Amazon.
For sure. Thank you so much. Next question is, are any of your inventions still used?
Yes, we're still using the crab cams, and a lot of the critter cams are being used right now. That's a really discovery. There's been a number of people. My friend Bill Hagee has developed a lot of them. So that technology is still being used. The shark fin was unique. I've had a lot of inquiries that people wanted to buy them. And if you look at my website, I just said, no, I'm not into this. But sometimes I get people begging me. One guy in Australia said, just name your price, that's it. And I said, shipping it alone is going to be $300 over there. Says, I don't care, I don't pay for it. So he lives in Australia, and he wanted to take this on the beach. So I had to build him one. The other one was David Merlini, a magician in Italy. And Dave and I became very good friends. He takes after Houdini. So he has this one trick where he's set off a bridge at night in this steel box that's floating to the bottom, and he escapes from the steel box. So he had to have a couple of these great white shark fins swimming around him, off the bridge to make sure that this event was pretty good. So stuff like that. But, I'm not really in production of this stuff. This is just more hobby type stuff.
For sure. Thank you so much. Next question is, how has COVID affected your work?
Well, the reason why I developed the thruster was because I was in isolation. I live in Southern California, so we had some people who really didn't believe in masks and didn't believe in self-isolating. So I thought, it's best just to come up with a project that, I can stay home and do. So I had a bubble of 2 or 3 friends. We now all have our shots, and so we can periodically get together, but still use discretion and work on these projects. So again, having that time has been an inspiration. Otherwise, I would have been up on my boat and playing with crabs or pigeons or something like that. I don't know.
Thank you so much, and congratulations on your shots. That's really great to hear. Next question is, what's the next adventure now that you have your shots?
I want to go back to Canada to continue this work with the Dungeness. One of the things that we found is the traps that the commercial fishermen are using can be modified to make them even more effective and more easy for the females and the small crabs to get out. So that's one of the things that we're going to be looking into with the fisheries department. The second thing is, hey, I want to go out and try some of these thrusters, but I've got a new design for a diver thruster that is totally hands-free. It's nothing that you hold. It's nothing that you put on your wrist. It's nothing that you put on your legs. So this could be a patentable project. So I'm working on the thrusters on that. And if I do that, I'll get down to Bonaire. I have some friends that have a place on Bonaire, and I stay down there with them. Nice warm water, clear conditions. So diver propulsion, hands-free.
For sure. Thank you so much. We got 3 more questions from the chat tonight. First question comes from Jay Nunn. Jay wants to know, do you have any ideas for projects that technology just hasn't caught up to yet? Something you need much smaller cameras for, or much more powerful batteries?
Let's share the future on that. Let's see if I can show you something. See if I can get something really quick here. Okay, to answer that question, I like to give definitions because sometimes you explain things and they're just too small. So let's talk about smaller cameras on land critters. I was down in an island called El Dabra in the Seychelles, and they have more giant tortoise than even the Galapagos. So we wound up putting cameras, much like we did on the crabs, on the tortoise, and had them move around so we can get their movement, send it back by microwave. And again, the units were kind of large. So if we talk about something small, this is the latest generation. Let's see this. This camera is less than a sugar cube. It is a wireless high definition camera. You see that? And what it is, it's on a little stainless steel clip. Actually, this was a drapery clip that I put it on. And what it does is it goes on my little amphibious vehicle that I bought in on Amazon for about 30 or 40 bucks. This will go on land and in the water. So what I do is magnetic thing. I put the camera on here. So now I can actually take this thing around the beach, move around, whatever it is, send the video back and record it. Now, when you say send the video back, what I send it back to, I have a headset. So the headset allows me to see the image in real time, but even in daylight. And it has two antennas, directional antennas connected with it, and it's got a recording device on the inside. So if I see something I want, I just press a button and it's recorded on an SD disk. Now, this looks like a fancy piece of equipment here, you know, with a set color high definition TV. This was on sale at a site called Hobby King for $29. These cameras sold for about $30 a piece. So you don't have a lot of money in high technology right now. If you just shop around, there's things that you can do to put on terrestrial animals and everything like that to make it, you know, make it pretty interesting. But I think the secret, and the project that I'm on right now is having to do with monitoring the southern killer whale population, is streaming video. And the guy that solved this is Elon Musk. He's got that new satellite system out now. You're paying $500 for the box and about $100 a month. You can live stream 6 cameras from anywhere in the world on this thing. You can even do it from a boat at anchor. The technology is absolutely incredible. And I think that's going to be the wave of the future. We'll be using this technology this summer to, again, monitor these killer whale populations, the southern killer whale populations, as they move around Vancouver Island and into the San Juan Islands. That's the technology to watch, in my opinion.
Thank you so much. I think you answered one of our questions in that answer. So, final question from the chat is from LD. LD wants to know, do you think electric systems for water propulsion will one day replace current fossil fuel-powered engines for large commercial or military vessels?
Well, looking at the rate that we're going in terms of automobiles, there is a high probability of that. Battery technology is increasing like computers is increasing with the new solid state batteries, and just even the stuff that Tesla is doing on these new batteries to get 5 times the energy out of it with the new technology. So we're not nearly here yet, but I think in our foreseeable future, which is probably in our lifetimes, we will see such a breakthrough that is going to be feasible.
All right. Well, thank you, Joe. Very much appreciated. Fascinating show, inspiring to all of the would-be tinkerers out there. I'm inclined to go out and start trying some things myself. So, very good program. Thanks for coming on.
Thank you, Ken.
Thank you, everyone, for tuning in tonight. If you liked what you saw, please come back every Thursday night. Follow our YouTube channel, subscribe, get notified when new videos pop up. We have podcasts also. Follow us on social media. Adventurers Club of Los Angeles. We'd love to have you follow and benefit from what we get to share in. Have a great night, everyone. All right.